Hi, so this is a very condensed version of how to use PyTest. I have tried to cover breadth of information so that you can get started, set up your test in a way that it runs automatically, and given enough information that you can dive deeper. But for detailed information, you can click the links that I have in the blog, or I'll also put in the YouTube video here. So to get started, let me first start with the demo that how a typical PyTest setup works. So I'll take my let me first walk you through the repository which I'm testing. So this repository is open source repository. I'll put the link here. So if you see the repository structure here, there is a backend folder where all the backend code is there. And then there is a test backend where I have all the tests for the backend. And I have kept almost the same folder structure of the backend and the test backend here. And I've defined a file here, which is the pytest.ini file, which is opened. So this file tells the PyTest like how the tests are organized, and will cover in details how it works. But at the very broad level, it covers that run all the tests in the test/backend. And then we can use a function, which is, let me run here, continue without continue collection without error. So this tells PyTest that run the whole test. Even if, let's say, few test fails, it will continue and give me the end report. Now you see what's happening is that it's collecting all the tests that has been written in this folder in multiple files. It will run all the tests, and at the end give me the report that how many tests passed and failed. And that makes it really easy for me that every time I have to merge a PR or do a commit, I'm assured that all the things are taken care of, and the changes we are making are backward compatible in some ways. So 8 tests passed, which are all the tests that I've written. It's a small repository. So let me start with how to use PyTest. So the setup here is that first you need to install certain libraries which are listed here. Just copy, paste, and install. And then the first thing that you have to do is to define this pytest.ini file that I walked you through. And at the basic level, that if I take you to the file, what you have to say is that first is that what is the verbosity or things that you should run the PyTest with. For example, every time I write PyTest, it also includes -v and -s here, and -v is that it's more verbose logs that come. Then what is the log label? So here I have said info, and what is the test path, which is I have said every test that is included in the test/backend. I have also said that don't run the test in the mock directory here. And then I have not included any pattern of the file. So I want all the files within the folder, this test-backend to run. And then I have set certain patterns for the Python classes and function. So most of the classes that you will write for the test, you will use the capital TST. And then for function, you will use this as a prefix. So I have included this here as well to include when running the test. Now, depending on what convention you are following, you can change it. So coming back to here, so once you define the files here, I have included extensively and put the comments on how you could customize here. Once you define this, you have to also decide the folder structure. Now there are two patterns that I have seen. One in which you replicate the folder structure as is, and you use test in front of every file. If you use this, then you can make the Python file here test. Then wildcard, because of all your Python files are all your test files are including test prefix in front. If that is not the case, where you don't want to put test all the time in front of your files, in that case you can just say wildcard. So that is your folder structure. Now I have also included certain sort of basics on writing tests. For example, what are unit tests, integration tests? Very simply speaking, unit test is where you have isolated test on one aspect of your function or class, and you have mocked everything else. While integration testing is end-to-end, typically one PR will have a couple of integration tests on everything that you want to run together. Now, a way to write function or the test all the time is that first you define all the dependencies or input to a function. For example, let's say you are creating a building, then all the input you define, which is the arrange part. Then you act, which is add all the input, and then the final output is your building. And then you assert what sort of building it is. Is it a Victorian style building, or in this case, the C value is equal to 3. Now, there are a couple of best practices when you're writing the test. For example, test should be isolated. Make sure that there's not the case that if one test fails, all other tests will fail as a result. And then one of the convention that I follow that makes it easy is to always include the functionality that is being tested and expected behavior within the test name. Why it is helpful is that when you run the PyTest and things fail, you will see the test name. And if you have written the test name nicely, you can just directly jump to that function. You know why it's failing and what's not working. So it makes the debugging aspect a lot easier. Next, I'll cover the most crucial aspect of the writing test, that is mocking and patching. So very simply speaking, mocking is that you create a pretend object that this was my real class or real function or a method, but I have a mock or a pretend object that will behave almost similarly, but in the way that I control. For example, it will return only this value, or it will return these set of values. It will have this side effect. So all of these you can define with the. So here is how simply the mocking works. That first, let's say a dependency is that what we want to mock. And then we can define that what is the return value in this case. Like we can fix a return value as 42. And then within the function, we are returning this dependency. So that means this function, wherever it will be called, the return value will always be 42. So you can test that just take the result and then assert that result is equal to 42. And you can also check that whenever this function is called, it should have called this dependency once. So that also makes it really easy that once you have mocked a different function, then you can assert that whether that function was called or not. Now there is magic method. An idea here is that Python has this dunder method or magic method, like when you want to print something or you want to create a len, instead of writing a lot of code to achieve that, if you use magic mock, these methods are already created and you can just use, for example, in the case of str value, that string value that you want to print, you can just define the return value in this case. Now, similarly, there are ways to do this for mocking asynchronous object. You can also define side effect. Now, all of these, I don't want to go deep, but whenever you need it, you can just come here and use it accordingly. The second important aspect here is patching. And patching is like temporarily changing the way a method or function or something behave. So you literally put a patch or a sticker that this is how this function method should behave. So an example here would be that I imported patch, and then for this module.className, so file name.className, instead of this being called, I want this mock class to be called. And this mock class I've defined as a mock object. So I can control its return value, for example, and its side effect. And I can also assert that this function was called at least once. So for example, let's say you called a weather app, and instead of calling the weather app to return the real temperature, you can put a patch that it returns the same temperature every time that app is called. Now that's one way of controlling the patching. Now I've given certain examples here that how to patch a method or property, but one of the core aspects that I wanted to highlight is what to patch. So you should not patch where the function or the method is defined, but where it's used in the code path. For example, if I go in this particular code and go to backend and go to fast API, and let's say I want to do test for this callback function. So in this case, kindle.fetch token returns here. So I don't have to go to where this fetch token is defined and mock that, but instead if I am running the test on this one, I just have to mock this aspect, that whenever kindle.fetch token is called, this particular authorization response to be returned. So that's one way, that go to the execution path and mock where that comes in versus where it's defined. For example, if you go here, this is where it's defined. Now, there are two ways to define patching. One is the decorator way, where you define, put everything in decorator and pass the value that has to be mocked, that has to be replaced with. And the second is context manager. So within your test function, just put in this format, which is patch, and within bracket your class name and then what it needs to be replaced. Now, when to use what? Generally, you would want to use this way if the whole test has to patch that value. If within the test locally you have to patch, then this is a better function. This is the better way. Now, things get more complicated. If you want to patch multiple things, then order is also important. So here in this case, first decorator is replaced by the mock class 1. The second decorator is replaced with mock class 2. So take care of the order when you are patching multiple things. Now, one of the easier way in PyTest to patch things is monkey patch. And this is pretty useful where you want to patch environment variable, system path, and also the way you write patch is more readable in this case. Now, where this came from is that it's monkey patching came from gorilla patching, which is used to be a way to change the code in a very sort of hacky way. So for example, here, instead of putting @ or context manager, you just say monkey patch.set attribute, and this module instead will return this mock function. So that makes it really easy to patch things. And for example, you could set environment variable to be this particular value. So for example, you want a MongoDB database and you want a different endpoint for test. So you can set environment variable to run the test locally or in memory to do things. And similarly, API keys and all you could change for the testing. So monkey patch, I think would be helpful if you want to write more readable testing and also like change environment variable or system part and these sort of things. So this is one example that I wrote here where monkey patch is more helpful. Now there are certain other things that wanted to mention about is fixture. Now fixture is pretty helpful when you want to leverage things, leverage or input across the test. For example, I'll show you an example that I wrote here in this code. So in the test backend, if I go to DB, so here I've defined a fixture where I've defined a local DB connection. So instead of sort of polluting my main DB, I have defined a local DB that needs to be used, and I've defined clear creation of this DB and then deletion of this DB. So this fixture makes it really helpful to tear down the resource as well. And I have defined the scope here module, which means within the file I can share that. So for all the function, I just pass this test DB, and instead of calling the real database, it calls this test database to do all the things. So this makes my code very easy to read and also removes the code duplication. So that is pretty useful, is to use fixture in this case. Now the fixture scope can vary. It can be defined for a function, a class, or a module, which is the example I shared. Now, generally, you should be using yield because this makes it really easy to tear down, and you don't need to do this after the function. But in certain cases, you might just want to use return where no tear down is required. Now, there are other things that is pretty useful, which I might have covered here, which is conf test. Yeah, so conf test is, let's see if I have defined conf test. Okay, I have not used here, but in certain cases, if you want to share the fixtures across the files, then you can define in conftest file, conftest.py, and then in the entire directory, for example, you could share those fixtures. Now, in the last sections here, I have covered like how to run the test. So for example, you can run pytest / coverage report. It gives that within this directory what is the test coverage. You can run pytest for a specific file. You can also run -k and then a specific method or function that you want to run test against. You could run, for example, if you are writing test and you are sort of you want to only work on tests that failed, then you can use this -- last failed. You could also see the test in form of a Python server. So I can give you a demo here. So the way to run this would be first run this command here. So I want the coverage for backend, which is the code that I want to test against. And I also created a HTML report, and I have written that continue on collection, which is the same thing. Now this will take some time. So what I will do instead is run the server here and say run a Python server. So once I run the Python server, I can just open this. And so this creates the Python server, and I can go to HTML coverage and see the coverage reports. It gives me file by file what is my test coverage. I can go function by function as well, and similarly classes. So this is a very handy way to see that what is your test coverage. So with that, we come at the end of the section. I have also at the end given you a glossary that what are different terms and definition that you can just refer here. So let me know in the comments what are the things that you found useful and what are the things you want me to cover in details in the later videos on PyTest.